Hello, and welcome to Mastering Database Design. I'm your instructor, David Baker, and this course is brought to you by Creative Online School. Before we get started with the actual course, I'd just like to introduce myself, just very briefly. Again, my name is David Baker, and I have at least 3 years of work with SQL and NoSQL databases. I also have worked with many other languages and how SQL interacts with other languages. This course again is brought to you by creativeonlineschool.com, where they have many other courses if you are interested in learning more about a certain topic or interested in getting started with a new topic. So what you will be learning in this course is, first off, what a database is, what tables, views, and stored procedures are, which tables are simply just what is stored in a database. We'll understand the differences between the types of commands and the command languages used in databases. We'll understand database constraints, entity relationship, normalization of a database, what RDMS stands for and what it is, and then we'll start looking into what NoSQL is, which is just a different version of a database. And then finally we'll get into the differences, advantages, and disadvantages of RDMS and NoSQL. So let's go ahead and get started with what a database is. So a database is simply a place to store information. It is used for cooperation between different platforms and inherently increases overall efficiency of work. The way that this works is a database is hosted on a server. A server is can be accessed by many people, and each database holds what are known as tables. These tables hold information that is stored in a very organized manner, and each item or each column inside of the table is defined and stores a specific type of information. So what we're going to be working with throughout this course is the database of Creative Online School, and then the tables of owners and pets, which we will get more into in later videos. This is just going to be, this video is just introducing you to what databases are and how everything is set up. So the server that we're going to be hosting our database on is just going to be our local host, so it's going to be on our own computer. You can host them on servers such as Amazon Web Services or any other type of server that you have bought or pay to use and to actually get out onto the internet. So we're just going to be working on our local host. We're going to be working in a database called Creative Online School, which we will be creating, and then we're going to just use the tables, owners, and pets, which we will also create in the next video. So in the next video, what we're going to be looking at is tables, views, and stored procedures. I hope that this video has been helpful for you to just get into an introductory of what a database is and the format that is used for it. Again, my name is David Baker, and this video is brought to you by creativeonlineschool.com. In the previous video, we learned about what tables, views, and stored procedures are. And going forward in this video, what we're going to be learning about are the types of commands that are used in SQL. So there are 4 types of commands, being data definition language, data manipulation language, data control language, and finally transaction control language. We're going to look at each individual language inside of SQL. So let's go ahead and get into a MySQL server, root, type P. Alright, and then we're going to use the Creative Online School database. So we can view all the tables that are here and see our tables. So what we're going to work with first is data definition language, or DDL. And what DDL is it is simply the commands that are used to actually create and alter any information. So a more formal definition for it is a standard for commands that define the different structures in a database. So one of the structures being such as a table, or maybe the columns inside of a table. Whatever the structure of it is going to be a data definition language. So we can use create table cats, and then we'll just have ID is integer, not null, auto increment, and then just name var char 30. Primary key is going to be ID. And so what we just did is we used create to create a table, and we have defined another structure for this database. So we can show tables, and there we go, we have table cats. What data manipulation is, so going into DML, the next language, is the actual process or the statements used to manipulate the data. So what I mean by this is what is actually stored on a table. So data manipulation has two parts. It has the statement. So the statements are going to be such as insert, select, delete, update. So it's used for anything that is stored or retrieve any information. And then it has clauses, which is going to be from, where, stuff like that, that will tell you what the statement acts on. So we can do an insert statement, insert into cats, name, values, let's just say kitty. So what this will do is we're using the data manipulation language to actually insert information into cats. So we can view that it's there. Oh, excuse me, I forgot from. So also this select statement is also a data manipulation language because we're viewing the data. So going into the DCL, which is data control language, this is used for giving control or using admin privileges. So it's used by administrators to configure security access in relational databases. It complements the DDL and DML, where it allows or denies people, certain users, certain DDL or DML processes. So there are two commands in the data control language, which are grant and revoke. So what we're going to do is we're just going to create another user and grant them privileges so that we can see how the grant and revoke work. So we're going to grant all privileges on, so we have to define the actual database that we want to grant privileges on. And then we're supposed to define the table, but we're just going to say everything. And then we're going to make a username Baker at localhost. And then we'll set up a password, call it just password. Oh, excuse me. I spelled identified wrong. I always do that. So we can actually exit and log in as Baker now, using password PASSWD, use creative. So the first thing actually I should show you is show databases. If you noticed, we have less databases here because we are only granted access to the Creative Online School database. So we're going to use Creative Online School, then show tables. So you can see that we can do whatever we want here inside of the tables from cats. And okay, so let's go back and log in as our root user. And what we're going to do is we're going to revoke, let's do select. Select on Creative Online School star from Baker at localhost. Alright, so now we can exit and log back in as Baker. If we want to use creative online school. And now if we try, we can show the tables still. So we can show tables, but if we do select star from cats, what it's going to do is it's going to give us an error saying that we do not have the privileges. So this is how the revoke and grant commands work in the data control language. So it's used for just basic privileges and stuff like that. So, however, you can see that we can still use insert. So insert into cats name values kitty cat. So we can see that we inserted it, but we are not allowed to view again. So we'll exit from here and go back into our root user. Creative Online School. And then we'll select star from cats. And you can see that it was actually inserted into the table by another user, but we just weren't allowed to actually view it in that user because we revoked the select command. So you can do this with any type of command inside of SQL, just grant or revoke. Next, we'll move to transaction control language. This is actually used for merging commands and used for such as rolling back and using a save point. So if you are familiar with Git, what you can do is you can save a spot and you can branch off and go back to that certain spot. So what we're going to do here is we're just going to start transaction. So start transaction. Excuse me. And so now what we can do is set a save point. We can save point and we'll just say first save. And now we're going to mess with the table a little bit. So insert into cats, a name, and values. Let's just do Mary. And let's make another save point. Second save. And we'll insert one more thing. So I'm going to show you the table right now from cats. So you can see that we have Mary in there, and now we're going to insert another item. We'll just put my name in there, and we'll look at it again. So now we have 4 items on the table. However, if I do roll back, and then second save, roll back 2, excuse me. What did I name this? Oh, I spelled it wrong. That's why. I have trouble with my ends sometimes. So we'll just roll back to the actual point that we need to. Roll back 2, and then we can select star from cats, and there we go. We have successfully rolled back a step. So we rolled back from the step where we had David, and now we don't have David anymore. And we can roll back to the first save as well. And then here we go. And then if you want to end your transaction, what you do is just press commit, and now there are no rollbacks. So this save point doesn't exist because we have committed and stopped our transaction. I hope that this was helpful for understanding the types of commands that are used in SQL. And in the next video, what we're going to be looking at is actually the conditions used by SQL for certain columns and how to define them. Again, my name is David Baker, and this video is brought to you by CreativeOnlineSchool.com. In the previous video, what we learned about is what a database is and the simple layout and structure of it and how we will use tables to store information. In this video, what we're going to be learning about are what tables used and stored procedures are and also how to use them. So let's get started with what a table is. A table is simply a place to store information on a database. A table has unique fields, which are called columns, and they store information that goes inside of the table. As you can see here, we have the owner's table storing information about a person and the pets table storing information about a pet. And we have an ID, name, gender, and phone field for the owner's table. And then in the pets table, we have more information about pets. But what I would like to draw your attention to is that in both tables, we have this field called ID, or this column. And this must be unique, and every table must have what is known as an ID field, where it has unique information that every row has that is individualized to each row, so we can reference it later. And then in the pets table, we have what is known as a foreign key. And what a foreign key is used for is for a relationship between tables. So what we can see by these arrows is what is known as a one-to-one relationship, where one person, or in the table owners, is referenced by one pet in the table of the pets if we ignore this third row. And so this is a one-to-one where one owner owns one pet. But we can also have what is known as a one-to-many, where one owner is referenced by many pets. So basically, one owner owns many pets, which is a very logical statement. So let's just go into a SQL database, and what I've gone here is I've just gone ahead and shown you that we've created the two tables pets, and we're going to look at the columns, select columns from owners, show. And what this does is it shows us that all of the columns inside of the owners are individualized, and they all have to have a data type. So for our ID field, we're simply having integers, and then we have varchars for the rest of our fields for name, gender, and phone. We also have what is known as a primary key, and it is listed there. So then going into the pets table, we're just going to show the same information, and we can specify if we want integers, we can specify if they can be null or not, so empty, and then what this is it's just saying that this is the foreign key field. And you can also set default values and extras, which we're going to learn about in a later, or known as constraints, which will be this auto increment. So let's go forward and start talking about what a view is. So what views are is a virtual table that stores queries or information that is returned from a query. So you can view a query by simply, let's just do a simple query of select star from owners. So we're just going to show everything in the owners table. And there we go, we show everything. But you can create a view, so a virtual table, by doing these queries. And we're just going to go ahead and create a view of name and phone. And we're just going to select name and then the phone from owners. And what it does here, as you can see, is it gave me an error. Oh, I put SA and not as. There we go. But what you can see is it does not actually show the output. Instead, it says the query was okay, but we didn't affect any rows. But if we do show tables again, we actually have an extra table, and we can select star from name and phone. And this shows us the information of the query that we returned. And going forward, next we have what are known as procedures. What a procedure is actually a subroutine that is run on the server. They're used for reducing traffic, and they can are very light and easy to switch between SQL platforms. So we're going to go ahead and create a stored procedure, and we're going to first change the delimiter to a / because it's easier to create a procedure this way. And we're just going to create a procedure called counting. And it's going to be a simple procedure where we're going to count whatever is in. So we're going to count everything from owners and end. And then we'll have our //. There we go. And then we can call this by simply saying call counting // excuse me. And there we go. We get the count of how many rows there are in owners. So a stored procedure is basically a program that can be run on the server. I hope that this video has been helpful for you in understanding what tables, views, and stored procedures are. In the next video, what we're going to be learning about are the types of commands that are in SQL and when to use them. Again, my name is David Baker, and this video is brought to you by CreativeOnlineSchool.com. In the previous video, we learned about commits, save points, and rollbacks and how to use them inside of a database. Going forward in this video, what we're going to be learning about are database constraints. Database constraints are used to control information, and they are part of the schema definition. So it is actually what defines what can and cannot be inserted into a table or inside of a column. Now, these constraints are not only used at a column or table level, but they can be across an entire database on multiple tables. So let's go ahead and get into our MySQL server. Just logging in as our root user. And we're going to use the database that we've been using the entire course, Creative Online School. And we're going to see the tables that are in here. So we have 3 tables. We're going to be altering the cats table today. So we're going to look at the columns inside of the cats table. And we have 2 columns, the ID and name, and they are defined as an int and varchar, so we must have a type. And then everything out here is just extra stuff that we can define. We can define whether it can be null, we can give it a key that defines what can be added or how the actual column behaves, and then a default value, and also an extra. For this extra we have auto increment, which is always used the primary key is always going to be associated with auto increment. So if you define a column as auto increment, it will automatically be the primary key because you can only have one auto increment inside of an entire table. So let's go ahead and start looking at constraints. First constraint that we're going to look at is not null. As it suggests, not null means that you cannot make anything inside of the column null. So we're going to just add a row column here called age and set it as an integer. And if we select star from cats, we can see that it is currently null. So what we want to do is modify it, the column, so that age cannot be null and not null. However, we have an invalid use of null because we're trying to say that it is not null when it already has null values. So what we need to do is update cats set age to, let's just say, 0. There we go. We rerun and there we go. We have now age is 0 and everything, and we can see from our definition that it can no longer be null. Next, what we're going to have is unique. Unique means that anything in that column cannot be a duplicate. So right now we do not have it as unique. As you can see, we have 0 and 1. 0, excuse me. So what we're going to do is alter table cats, add unique, and the column that we want to add it on. However, we can't because we have a duplicate entry for 0. So we just need to update our table. So we're going to set age to 1, where ID equals 1. Now we're going to add our constraint. There we go. Now we can see that this constraint is added because we have this key uni on the age constraint. The next type of constraint that we're going to look at are what are known as primary keys. What primary keys are is how everything is referenced inside of a table. So primary keys must be unique for each individual row. That's why we usually have this ID field inside of a table, because it lets us reference each individual row and know that we are referencing each specific row. So what we're actually going to do is first take away this auto increment function so that we can drop this primary key. So we're just going to alter table cats, modify ID to be not null, and not have it auto increment. Excuse me, 2 L's for null. And it also needs to be an int. Excuse me. There we go. So now we can see that it cannot be auto increment. We're just going to drop the primary key now, alter table cats, drop primary key, show columns from cats. So we can see here that we dropped the primary key, but it automatically went to age. This is because age is already defined as being unique, so we know that there's not going to be any duplicates and is the next best runner up for a primary key. The way that you add a primary key is you just alter table cats, modify column ID to be int, not null, add back the auto increment, and say that it's the primary key. There we go, and we can see that our primary key has gone back, and we did not lose our unique from the age. Next, what we're going to have is the foreign key. And what foreign keys do is they reference other tables inside of your table. So we're going to add another row called the owner ID, and we'll just define it as an int for now. And what we're going to do is alter table cats, add constraint f key owner ID cats, and this is just going to be the name of the foreign key that we're adding. So you can have multiple foreign keys if it needs to reference multiple tables, and we just tell it which row inside of this table is going to be the foreign key, and then where it references to. So we have the table and then the ID. There we go. And now if we show columns from cats, we can see that we now have this mul as a key, which means that it is a foreign key. What you can do with foreign keys is you can select specific individuals inside of other tables from an outside table. So let's just set a value inside of cats to be 1 to reference the first ID in the owners table. So update cats set owner ID equal to 1 where ID equals 1. There we go. Now we can select star from cats, join owners, select star from chat, join owners on cats dot owner ID equal to owners.id. And here we go, we can see everything that we selected from the cats and everything that we selected from the owners table. So this is just a simple way to reference other tables. The last constraint that we have is known as a check constraint. So in SQL, you can add check constraints. Just how we've added the unique constraint. You just alter table cats add check age is greater than 20. So we're just checking to see if age is greater than 20. But we can still update cats age, set age to 23, where ID equals 1. And you see it doesn't give us any warning at all, even though we updated it. And we can see that it doesn't do this. So in MySQL, what it does is it actually puts in the constraint, but it does not parse the constraint. So what we have to do is actually add a trigger. So let's just go ahead and do that to add a trigger to update. So create trigger check age on update. This is going to be the name, and before we update, so when we're going to do it, and then what table we're going to do it on. And for each row, excuse me, I spelled that wrong. Let me start over here. For each row, again, if new.age is greater than 20, then we want to signal set state. We're going to make an error out of this 4500, and then we're going to set a message text age must be under 20, and if end limiter excuse me, I said this wrong. It needs to be SQL state and not set state. So let me just change my delimiter back, and we'll just go through this very quickly. Typos are honestly the worst, especially when you're coding inside of the terminal. So this right here, it just needs to be SQL state, not set state. So we'll just get that done. Then we'll set the message, and then here I can just type the rest. And if end. Here we go. There we go. Delimiter. Back to this. And now we try to update cats set age to 23, where ID equals 2, and there we go, we get our error. I hope that this video has been helpful for you on learning about database constraints. In the next video, we're going to be learning about entity relationship diagrams and how to use them. Again, my name is David Baker, and this video is brought to you by creativeonlineschool.com. In the previous video, what we learned about is how to make an entity relationship diagram using MySQL Workbench and the uses for decluttering and organizing with this form. In today's lesson, what we're going to be learning about is database normalization. Now, if you don't understand what database normalization is, this is a great video for you. What database normalization is the process used to organize a database into tables and columns. Now, you may think that this is pretty inherently simple. However, there are some rules that we follow when we are using SQL that make everything efficient, and it helps us minimize duplicating data and also helps us minimize our data modification issues. So when we're trying to insert or delete any types of data, we don't have to do it multiple times. We can do it one time and know that it is deleted. It also helps us simplify our queries. So when we're searching for information, it is much easier to search for information and find it. So the reason that we use these rules is because not everyone will follow the same practices. So there are three types of normalization. There's what is known as the first normal form, which is where information is stored in relational tables with each column containing atomic values with no repeating groups of columns. What it means by atomic values is that each column will have only one value and will not have multiple values within the column. And what it means by no repeating columns is that no two columns will be representing of the same type of information. Going on to the second normal form, it's the same as the first normal form, and in fact builds upon the first normal form, except it also adds to where all the columns depend on the table's primary key. We'll get into this later in the video, but you just need to know that this allows us to split up into more tables that better define what is inside of each table. And then going on to the third normal form, it builds upon the second normal form and includes all of the same rules, except for it also adds that all of its columns are not transitively dependent on the primary key. Now, what it means to be transitively dependent means that if you have two items, A and B, and A changes and it causes a change in B, those two items are transitively dependent and must be split into two separate tables. We'll get into this later in the video. So let's just go ahead and start with the first normal form. What I have here is just an entire table with a bunch of information. So we have an ID field listing each individual row. Then we have the name, phone, city, postal code, pet 1 name, pet 1 breed, pet 2 name, and finally pet 2 breed. The first thing that you may notice is that not every single column is filled in. We can see that David has 2 pets, Rebecca has 1 pet, and Jordan has no pets. This is perfectly fine because in each column it only contains one individual item, and this follows the rule of the first normal form, meaning saying that each column must have atomic values. However, it does not follow the rule of the first normal form where there are no repeating groups of columns, because when we have pet 1 name and pet 2 name, these are repeating columns. These mean the exact same thing and are a waste of space inside of this table. So what we're going to do is apply the rule of the first normal form and split this into 2 tables. So once we split this into 2 tables, what we have is an owner's table and a pets table. And what we have done is we have the ID, name, phone, city, and postal code from the owners because all of that relates to the owner. And then we have the pet ID, pet name, pet breed, and finally the owner foreign key inside of the pets table. What this allows us to do with the owner foreign key is reference back to the owner's table. The way we do this is we just put in here the ID of the owner inside of the foreign key, and it allows us to reference the table. As you can see here, we have this line with many prongs on the end. If you remember from the last lesson, what this means is that there is a one-to-many relationship, meaning that one owner can own many pets. As you can see, the foreign key 1 inside of the pets table is known as the owner David, as you can see right here. So David owns more than 1 pet. Going on to the second normal form. So the second normal form, again, is the same as the first normal form, except all the columns depend on the table's primary key. So everything must be dependent on the primary key. So what we need to do here is make sure that anything that is within this table belongs in this table. So if I have my name, David, and a phone number, those obviously belong together because each person normally has their own phone number. However, if I have my name, my phone number, and my city and postal code, those might not necessarily belong together because many people can live inside of New York. I'm not the only person living inside of New York, so it's not unique to me, or in other words, it's not unique to my primary key. The same goes with the pet name and the pet breed. We can have multiple pets belonging to the, let's say, yellow lab breed. So this is not unique to the primary key and must be split into a separate table. So what we do here is we split everything into their own table. This may look hectic, but I will explain everything to you. So what we have first in the top right is the cities table. So we have a city ID, we have the city name, and then finally the city postal code. This is connected to the owners in a one-to-many relationship because many people can live inside of each of these cities. So we have simply a reference to each city by their foreign key, or their primary key as a foreign key, and that is how we're going to be referencing them. And then what we have here in this owner's pets table is how you would normally do a many-to-many relationship. So if I wanted to have many owners owning many pets, what I do is I set up a separate table where it just includes their foreign keys. And this has a one-to-many relationship to each of the separate tables. And what I could do here is instead of having simply just one, so let's say the owner ID, the foreign key is David, so David owns the pet ID of 1 and the pet ID of 2. If I wanted also for Rebecca to own the pet ID of 2, I could input that here and it would not mess anything up because I would have another reference to simply Michael, and that is completely legal because, say, if a couple owned a pet together or a couple owned many pets together, that is how a many-to-many relationship would be viewed. And then we have a one-to-many relationship with the breeds because many pets can belong to a single breed, and these are simply referenced by a foreign key. So this takes care of the second normal form where each individual column must be dependent on the primary key or must belong to the primary key. Going on to the third normal form. The third normal form saying that each column are not transitively dependent on the primary key. This means that if I change a column in the owner's table, no other column in the owner's table will change. We can see a violation of this within the cities table. For example, if I change the postal code here, it will simply change the city because each postal code has its own city and vice versa. So what we will need to do is create a new table for the postal code and city relationship. However, what we can also do here is a little trick. We simply will put the postal code foreign key inside of the owner's table, and this allows us to change the postal code within the owner's table and be able to reference any single city, because each city is still going to be referenced by each postal code, but we can change it in the owner's table and it will not affect any other table within the owner's table. So this is how you go from a simple table of one table, and then you will learn the first, second, and third normal forms to make your database more efficient, more effective, and more useful for anyone. This allows you to collaborate easier among people. Again, you can see if you were simply looking for a certain type of breed or a certain pet in their breed, you wouldn't want to have to pull up all of the information about the owners. So this makes it easier for everyone that is trying to input information or receive information from your database. I hope that this video has been helpful for you. Again, my name is David Baker, and we have been learning about database normalization. In the next video, what we're going to be learning about is RDBMS. Again, this video is brought to you by creativeonlineschool.com. In the previous video, we learned about understanding database constraints. We would learn about what the primary key is, a foreign key, check constraint, unique constraint, and so on and so forth, and how we use them and how we control information that goes inside of a database. In this video, what we're going to be learning about is the entity relationship diagram. And what this is basically just a visualization of the entire database. So instead of just understanding the database in our head, we're actually going to be able to see it inside of a diagram. What this does for us is it helps us improve our concepts. It helps us visualize our concepts so that we can improve our efficiency and clear out any clutter. It's easier to see instead of having to list everything every single time and actually having to go through it. We can also see how each table is interconnected instead of having to just understand through our minds. So what we're going to do here is we're going to be working in MySQL Workbench to create an entity relationship diagram. And so I'm just going to create a new connection. And what I've done is I've just created all of the tables that we created in our previous examples. As you can see on the left-hand side, we have the server Creative Online School. Then we have the tables, and we have each of our three tables, the cats, owners, and pets, and you can see all the columns that we had before are still there, the ID, name, gender, phone, and you can also see for pets, we have everything. And so what we're going to do in order to create this entity relationship diagram is just go up to the database, and we're going to reverse engineer. And it's just going to ask us which host and server that we want to do it on. So we're going to do it on our local host on port 3306. Click Next. It's saying that it has everything set up to go. Then we are going to select the database to create our entity relationship diagram on. Click Next. And then we want to import MySQL table objects. And we just execute. It says it's successful. And we finish. So once we are finished, we have this diagram of how the entire database is interconnected. So as you can see, we have our table owners over to the left, we have our table cats up top, and we have our table pets on the bottom. And what you can do is hover over these links, and what it shows you is how these two tables are linked. It highlights the ID, and then it goes into the owner ID. And what you can see is right here, it has a single bar coming out of owners and multiple bar going into cats. What this means is it is a one-to-many relationship, the one coming from owners and the many coming from cats. If it were a one-to-one relationship, it would have a single bar coming out of owners and a single bar going into cats. If it were a many-to-many relationship, then it would have multiple bars going into multiple bars. As you can see with pets, it does the same thing. It's hard to see right here, but it has the multiple pronged going into pets. And we can highlight it and see which ID goes to where. We can also expand the indexes to see what our primary key is, and then our owner ID is the foreign key. I hope that this video has been helpful for you in learning how to create an entity relationship diagram in MySQL Workbench. In the next video, what we're going to be learning about is database normalization. Again, my name is David Baker, and this video is brought to you by creativeonlineschool.com. In the previous video, we learned about how to normalize a database going through the first, second, and third normal form. In this video, what we're going to be learning about is what RDBMS is, what it stands for, when to use it, and just what it's made up of. So what RDBMS is Relational Database Management System. So basically what it is saying is that it is a type of system to manage information, the storage of information, and it depends upon a relationship between items. You commonly see RDBMS used, or actually it is used in SQL, DB2, Oracle, and Microsoft Access databases, just to name a few. The reason that you would use RDBMS, the storage system, is because it is good for storage of multiple items with the same type of information. It is also very durable and efficient. So everything inside of an RDBMS database is only stored once, which makes it very minimal and not allows you to use less space on the database. So if we would like to see an example of an RDBMS table, we can see that we have what are known as the attributes up top. So just we have the name, street, city, and then some questions. And then we have what are known as the columns, so what belongs to each of those attributes. And then we have the rows, so the actual information that is stored in each attribute. So as we can see, we have the questions, the 4 questions at the end, and we are expecting answers of yes or no. So this works well with an RDBMS table because we know that the answer is going to be yes or no, so we don't need to store that much information. We can just have it set to be a data type of a varchar of, say, 4 characters, just to add an extra character just in case. And we can say that this is all that we're going to need, and this is all the storage space that we have to use for this type. And we can identify each type inside of each column. So I hope that you now understand what an RDBMS table is and what an RDBMS database looks like. Since we have been working with it the entire time using the MySQL database to learn about these databases. In the next video, what we're going to be learning about is actually NoSQL databases and how to use them, and also when to use them. Thank you again. My name is David Baker, and this video is brought to you by CreativeOnlineSchool.com. In the previous video, we learned about what RDBMS is and how it is used for all SQL servers. What we're going to be learning about in this lesson is what NoSQL is and when to use it. So what NoSQL is basically any type of data information storage that doesn't use the same structure as an RDBMS. So it doesn't have tables that are relational to each other. The reason that you would use a NoSQL type of database is if you're looking for information that is unstructured. So you're storing information that you might not know the structure that's coming in. You are using it for rapidly changing types of data. So you're getting a bunch of data from this website and you're not specifically sure what type of data you're going to be taking in. You're going to want to use a NoSQL type of server. Now what I have listed here are 4 different types of NoSQL servers. First, we have what is known as a key value server. And how a key value server works is very simple. If you know what a dictionary is, that is what a key value data storage is. It's simply where you have a key, and when you query for the key, it gives you what value the key belongs to that key. These are typically used with text, video, or JSON documents. The next type of data storage that we have is what are called document stores. You'll see this in the MongoDB database, and what they are is you have a key. It's very similar to what a key value storage is, but instead of just having one value returned, you will have all the information on that key returned. So instead of a single value, you'll get multiple values. Next, we have what is known as wide column stores. And this is a little bit complex, but you can think of it as a table type of data storage, except for the columns inside of the table can vary from row to row across the table. Also, within the table, the way that it stores information is not based off of the column, but is based off of the related columns. So if they're grouped together, if each column is related to each other and each row is related to each other. So this makes it faster for search ability. Next is what is known as a graph stores. Graph stores are database types of graphs structures, and they use graphs, maps, and query relationships to actually store information. And they provide index-free adjacency so that adjacent elements are linked together without using an index. So we actually don't have to have any indexes for graphs. So I just have the two simplest, the key value and the documents visualization for you. So for the key value, what you're going to simply do is put in the key David and you'll get a value Baker. And then with the document storage, if you put in the key David, you'll pull up a document with the information of David, where it'll have David Baker, maybe the street and city that he lives in, or a phone number. Thank you. I hope that this video has been helpful for you to learn about what NoSQL databases are, and hopefully that will get you interested in learning more about them. In the next video, I'm going to be comparing NoSQL to RDBMS servers. Again, my name is David Baker, and this video is brought to you by CreativeOnlineSchool.com. In the previous video, we learned about what NoSQL is and when to use it. What we're going to be looking at in this video is the differences and advantages and disadvantages of RDBMS versus NoSQL. So let's just go ahead and get started with the relational database model system, management system, excuse me. So RDBMS servers are typically extremely structured, and you can define what each data type is going to be and where everything is going to fit. So you know the exact amount of room that you will need to take up on a database. They are also typically easy to understand because you can visualize everything within tables, columns, and rows on a database. They're also very durable since they are defined through tables and rows. These are easy to manipulate, and they're easy to delete and insert and to keep track of. Also with RDBMS, they are relational through different tables, so you can interconnect several tables together and create information and create queries through these tables. And you also have high levels of control within RDBMS servers, not only as the table constraints, whether saying it can be not null, auto increment, primary key, foreign key, but you could also have a lot of control over who can control which tables and input information where, also who can view what kind of information. However, going over to a more NoSQL side, you can see that NoSQL is more unstructured. So if you don't know the type of information that is coming in and you want to be able to handle every type of information, this is when you're going to want to use NoSQL because it is unstructured and very dynamic. NoSQL also allows for a lot of scalability. So it is very easy to add or reduce the capacity within a NoSQL Server without disruptive in any of the communication or with any hardware. This allows you to work on your database simultaneous while it's actually taking in information and putting out information. Also, the performance of NoSQL servers. They are extremely efficient in the way that they work because they are so dynamic. And then the global availability. NoSQL servers can be launched on any kind of platform. You can have them on your handheld device, you can have them on an entire network of systems. They're very easy to connect in between devices, and they're very lightweight. And then finally, for NoSQL servers, we have flexible data modeling. So if you're looking to visualize your data in a more structured way of graphs and actually modeling your data, NoSQL actually offers this within its definition of a graph store. So that is very helpful if you're trying to look at your data instead of just in a table as RDBMS does. You can actually look at how your data increases, decreases, and the relationship of how it grows. Thank you for watching this course. Again, this course has been brought to you by creativeonlineschool.com, and my name is David Baker.
Hello and welcome to Learn MySQL with Justin Posey, brought to you by creativeonlineschool.com. A little bit about me. I have 9 years in web development, and my specialization has been in MySQL and PHP. There are other courses available at creativeonlineschool.com. In this tutorial, we're going to go over a basic introduction of MySQL, how to install MySQL Server, phpMyAdmin, and MySQL Workbench. We're going to teach you how to create databases and tables, how to import and export information from those tables, how to input, retrieve, and manipulate data with SQL, and some more advanced SQL techniques for those who want to get the most out of their system. Well, let's get started then. First, a quick aside about pronunciation. As you can tell, I've been calling it MySQL. That is the correct pronunciation. However, it is also commonly called MySQL. If you hear it called that, don't be confused. It's the same thing. So what is MySQL? Well, MySQL is a relational database management system, or RDBMS. According to a poll by Dell, around 90% of the 300 companies polled actively use these systems in their businesses. So as you can see, the RDBMSs play an important role for almost every company. MySQL is one of the most widely used of the RDBMSs in the world. According to the same poll, 41% of the companies were using MySQL, putting it in the top 3 along with Oracle and Microsoft SQL Server. So now that we know it's important, the next question is, just what is a relational database management system? Let's break it up into 2 parts. First, a database management system is simply a system designed to allow you to store and retrieve information from a database. For example, let's say you wanted to store a list of reservations. A database management system would allow you to put that information into a database, and it would store it for you and keep it available so that you could retrieve that data at any time. However, you can only pull out what you put in. Now, a relational database management system does the same thing, but it uses a particular structure for storing the data called the relational model. This model allows different pieces of information to connect to each other in a meaningful way. For example, if you look at the image on the right, you can see that there are 2 different sections of information, but despite these being stored separately, you can produce a combined section of the information. This is possible because both sets of information have something in common, the activity code. That commonality is what relates them, and storing information with those commonalities is what makes the database relational. So how does MySQL store and retrieve data? It uses something called the client-server model. In this model, the database typically resides on a server and is accessed via a client through the internet. A client can be an interface for direct manipulation, such as phpMyAdmin, or it could even be a website, application, or program which operates behind the scenes. Now that we know what a client is, let's talk about how a client communicates with the server. To do this, it uses something called SQL, or Structured Query Language. This language can be used to define, update, and query the database. A query is just a term for the set of instructions sent. Like any language, SQL has a specific set of syntaxes that when sent from the client to the server can then be interpreted by MySQL so that it can take the appropriate action on the database. A quick example of this syntax would be something like select name from person where age equals 21. We'll get into the actual syntax later in the course, but for now, that's how it looks. And the best part is that SQL is used by virtually all relational database systems. So you can use the same set of instructions no matter what your environment is. That's it for the introduction. In the next video, we will go over the different types of data that can be stored within MySQL. Welcome. In this lesson, we are going to go over data types. Specifically, what data types are, the most common data types, the data types that are supported by MySQL, how data types affect what you can do, and how to choose the best data types for you. So let's get started by going over what data types are. Data types are classifications for data that help to identify what kind of data is going to be stored, as well as how it will be used. What this means is that in effect, you can think of them as identifiers for the containers the data is going to be placed in. In fact, there is an easy comparison with something you are probably already familiar with. That's right. Just like the labels on these containers, data types determine what kind of information should be stored in the container. Also, just like these recycling containers, the data type labels aren't arbitrary. They matter because of what's going to be done with what's inside the container. If you put glass inside a paper container, then when it comes time to run the process, there are going to be problems. The same is true for data types. With that in mind, let's talk about what kinds of data types there are. Although there are dozens of different recognized data types, ranging from the common, like containers for numbers, to the obscure, like containers designed to store coordinates for locations in three-dimensional space, for now we're not going to be too concerned with the data types that are rarely used. We're going to focus on the data types that are most common, the ones you're actually likely to see. Those data types can be broken down into three broad categories. The first category is the numeric category. As the name suggests, these types deal with various kinds of numbers. The numerical types you are most likely to run into are integer, float, and decimal. The integer type primarily deals with whole numbers, while the floats can store numbers or numbers with decimals. However, it can round numbers and it truncates leading and trailing zeros. The decimal type is like the float type, but it stores the exact number without any rounding or truncating. The second category is called date time and relates to storing dates. The most common of these types are date, date time, and timestamp. Date stores only the date, usually in year, month, day format. Date time stores both the day and the time in hours, minutes, and seconds. Timestamp also stores the date and time, but it converts the time from its current time zone into the UTC time zone. And when you retrieve the information, it will automatically convert the time to the time zone of the requesting client. Finally, we have strings. Strings are one of the most versatile types because they can store all kinds of letters and characters, everything from a person's name to an account code that may have both letters and numbers together. The most commonly used string data types are char, varchar, and blob. These data types are a bit different from the others, as they all store the same types of information, but they store them in different ways. Char can store information of up to 255 characters in length, and it fills any remaining room with spaces, so it's always the same size. Next, we have varchar. Varchar, instead of having a set number of characters, is instead limited by the space that it is used by the data it's stored. It does not fill with spaces, so smaller strings take up less space. The maximum space used cannot exceed 65,535 bytes. Last, we have the blob. Blob data type, which stands for binary large object, can store up to 65,535 characters. However, it stores the text as binary data, ones and zeros, so it has to be converted back in order to be readable, and that requires more processing. Well, we've covered a lot of information so far, so let's pick up the rest of the lesson in the next video. Picking up where we left off, now that we know about data types, let's talk about how they relate to MySQL. MySQL supports all of the common data types and categories mentioned, as well as having specific categories for spatial types, and it has recently added the JSON data type, so it should cover almost any data type you're likely to have. Beyond that, it also allows for more efficient storage by supporting size-limited types. An example of this can be seen in the different scales for integers, which range from the tiny int with a max number of 255 all the way to a big int, which can store numbers of over 18 quintillion. This allows you to only allocate as much space as you will actually need. Now let's talk about how choosing a data type affects what you can do with the data. We have already mentioned several ways that the data type can affect the space used as well as your processing efficiency, but let's talk about something more tangible. That is, how the type affects what you can do with the data. For example, it is possible to store a date as an int or a string instead of as an actual date, and as long as all you are doing is storing and retrieving the date, that's fine. But let's say you then wanted to order the dates so that you had them from oldest to newest. Let's take a look at what happens in the chart below. When told to order the date, the system is going to order the integer by pure numeric value, while it orders the string alphabetically. Both of these fail to give you the date from oldest to newest, but the correct types allows for getting the correct dates in the right order. So now that we know how important the types can be, let's go over how to choose the best type for you. To do that, there are three primary things to consider. First, think about what you're going to be storing. That includes both what it is as well as its length. If all you're storing are small numbers, then there's no reason to use a string or a big int. That just limits functionality or wastes space. Also, consider how important it is to keep the data exactly as entered, or if it's okay for it to be converted in some way. Next, think about how you may want to organize or report on the data. If you're storing a name and a date, and you sometimes want it ordered alphabetically and sometimes you want it ordered by date, then you're going to need two separate data type containers. But if you know you will always need it in an alphabetical list with both name and date present, then it may be okay to store them together in a single string. Be careful though, as it may be too late if you decide later on you need them separate. Lastly, remember that this is a relational database, and as such, the data may be connecting to other data. It's always much easier to connect and filter data if both parts are the same type. Well, that's it for this lesson. Next time, we will go over how to install some of the programs you will need in order to use MySQL. Brought to you by CreativeOnlineSchool.com. Welcome back. In this lesson, we're going to be learning how to install some of the programs required to use MySQL, as well as some we're just going to be using in this lesson. The first two we're going to install are MySQL itself and PHPMyAdmin. Fortunately, we can get both of these in a single package called XAMPP. If you go to the link provided, you will come to this page. Now we could sign in with Facebook or Google, but I choose to just use the alternative download, which will take you to this page. You'll quickly have a pop-up which will ask you to save a file. Click Save. We could watch their installation video, but I'll explain everything you need. Now, as you see, this is downloading. I'm going to cut a little bit out here to save some time. Now that it's all downloaded, we just have to open the file, and it'll ask us to run it. You may get a little pop-up that warns about possible slowing down of the installation due to an antivirus, but it doesn't really have much of an effect, so just click Yes. Then you will click Next. And in here, we don't really need most of these things. We're just looking for MySQL, so we're going to uncheck all of these. Remember, we also want to get PHPMyAdmin. We're going to click Next. And you can select the installation folder. By default, it's just C XAMPP. You don't have to click to learn anything more, so let's uncheck that. Now it's ready to install. Unpackaging. And once again, I'm going to cut to the end to save you some time. Once that's loaded, it'll take you to the Finish page. And yes, we're going to go ahead and launch the control panel. It'll ask us to choose our language. and then you're going to see this easy to navigate panel. Let's go ahead and start Apache and MySQL. That's it. We actually have the prep work for a database already. And not only that, because we installed phpMyAdmin, we have a way to see it. To open phpMyAdmin, simply go back to your browser and type localhost phpMyAdmin. That'll bring you up to an interface where you can see that we now have MySQL installed and some test databases that come default on the system. We're not going to go into actually using this just yet, since this is just an installation video. We'll move on to the next thing. If you're not using Windows, then the installation instructions provided already may not tell you all you need to know. For XAMPP, if you're on a Mac, you can use the download location I provided in Figure 1. After downloading, just open the downloaded file. It should be named the same as I listed here. Drag and drop the XAMPP folder into your Applications folder. That should complete installation. And then, to start XAMPP, simply open the XAMPP control by going to /applications/XAMPP/XAMPP in your control finder. And from there you can start Apache and MySQL. If you're on Linux, then you will need to use this location for download. After downloading, you're going to need to change your permissions on the file so that it can be executed. I've provided the command to do that here in Figure 2a. After that, run the installer. The command for that is in 3a. Once it's running, you can just follow the prompts to install. It should be just like the Windows version. After installation, to start XAMPP, enter sudo/opt/lamp/lamp start. That'll load everything and should get you back where we were in the video. Speaking of videos, that's it for this one. We'll continue our installation with SQL Workbench in the next video. Next, we're going to install MySQL Workbench. It's similar to phpMyAdmin, but also has a few bells and whistles that we may want to utilize. Let's go to the download link, and you'll be taken to this page. Now, if you read carefully, you'll see that there are actually a couple of other things that need to be installed in order for MySQL Workbench to work. One of those is Visual C++, and the other is Microsoft.NET. I already have .NET, and you may too, but we're going to need to install this one. If you need both, the installation is the same. So let's click here. It'll take you to this page and ask to select the language. Next, it'll ask you whether you have a 64-bit computer or 32. Click 64 if you have that, which is what I do. Click Next. It's going to start your download. It's fairly small. So now that that's downloaded, we'll just click on the executable, click Run. It'll open up and ask you to agree, install, and it only takes a second, and now you have it installed. Simply close this. Let's go back to the original page, and now we're ready to install MySQL Workbench. It uses something called the MySQL installer, so we're going to go ahead and download that from its download page. If you scroll down a little further, it'll have two different options for you. Let's use the smaller one, as it doesn't download anything we don't need. Scroll down. You don't have to use or sign up anything. Just click No Thanks, Start My Download. Save file. It too is fairly small, so let's open it. You may get a small warning, but this is from Microsoft, it's harmless. Click OK, Run. It may ask if you want to upgrade. Just say no for now. I accept. Next. Now we only want part of this, so we're going to go to Custom, Next, Open Applications, MySQL Workbench, Continue Opening, and select MySQL Workbench. Now if you don't have all the necessary components, this will be grayed out and it'll tell you what you're missing. Just click over here once you're done, and click Next. That's it. Now we're ready to execute. And it's begun the installation. Once the installation is complete, just hit Next, and it'll ask if you want to launch. We will. And that's going to bring us to the setup. Now, To create a new connection, simply click the plus right here, and you'll see the connection window. First, let's give it a name. Let's call it Example Database. Next, we have the connection info. If you're connecting to a server, you may have to modify this a bit to connect to the right place, but for now, we're connecting to the instance we just made, which is local, so this is all already correct. Next, click OK, and now we actually have one set up. There may be a short warning, but it's just telling you that Workbench and the MySQL version we installed are different. It's no big deal. And now you've created the connection so that you can see the database that we created earlier. Now there's nothing in this database yet, but we'll go over that in our next video. For now, let's just talk about the differences in installation if you're not on a Windows machine. If you're on a Mac, you can get the same file we did earlier at the provided URL here. Once it's downloaded, double-click the downloaded file, and then drag MySQL Workbench icon onto the application folder. Once that's done, you can now launch the MySQL Workbench from the Applications folder, or from the command line. If you want to do it from the command line, the command is below. If you're on Linux, then you can get the download from Workbench by selecting your system from the Selected Operations System menu, but you can also get it automatically. All you have to do is type sudo apt-get update, hit enter. Quite a few things may load depending on what updates you need. Once that's done, type sudo apt-get MySQL Workbench, and it should install it for you. That's it. Now that we have all the tools installed, next time we'll go over how to create databases, tables, and columns. This has been brought to you by CreativeOnlineSchool.com. Hello. In this lesson, we're going to go over the differences between PHPMyAdmin and Workbench, how to create and update database, tables, and columns in both PHPMyAdmin and Workbench. We're going to go over the principles of table design, as well as go over the uses of users and their permissions. We have already went over how to install both PHPMyAdmin and MySQL Workbench, and later on we will be demonstrating how to do some basic tasks on both. But for now, let's talk about some of the core distinctions between the two. First of all, MySQL Workbench is a desktop software. This means that it is installed on your local operating system, and it can connect from there to different servers. This is helpful if you need to manage databases on multiple servers. PHPMyAdmin, however, is a web-based tool, and is designed to be set up on the server itself. This means that it can be accessed through any browser and is not limited to a particular local device. This is helpful if you often use different devices or have multiple people working on the same server. Also, it's worth noting that PHPMyAdmin is a bit more streamlined and is often easier to learn for new users. MySQL Workbench, on the other hand, contains some added functionalities like server administration and database modeling, which can be very useful when trying to visualize complex data relations. Okay, so now let's get started by showing how to create databases, tables, and columns. We will start with PHPMyAdmin. Now remember, to open PHPMyAdmin, just open a browser and type localhost/PHPMyAdmin. If this was installed on a server that wasn't on your home machine, you could just put the server's address there instead of localhost. Next, to create a database, we simply go over here to the left and click New. Choose the database name. I want to call it Person. And then choose the collation type. Now collation's a little bit of a tricky subject for people because there are a lot of options. But basically collation just sets the language that your data is going to be interpreted in. And most people don't know the language that their data is going to be in, because a person's name, if input, could be in German, Spanish, or Chinese. So what we need is a good general way to sort through all of them. Fortunately, we have a good option, and it's what I use for most of my data. It's called UTF-8 MB4 Unicode CI. This uses Unicode formatting in order to sort things, so it doesn't care what language it's in. In case insensitive just means it treats capitals and lower cases the same. So let's create our database. Now that we have a database, it's prompting us to create a table. You can set the number of columns and the name right here. Now every person has a name, so our first table we're going to call name. And I'm only going to use 3 columns for this because we're going to keep it pretty simple. Now click Go, and it brings us into where we need to input the information. Remember those data types from earlier? This is where they come in handy. So our first column, I'm going to call it ID. It's always useful to have an ID because that way you can reference it in your other tables. And this ID is going to be very special. It's going to be our primary key. You select that here, primary. Now what this is going to do is it's going to say that this is the key thing that we're going to use to access other data types. So click Go. Now as an ID, we're going to want to increment it so that it's always unique. You don't want 2 IDs to be the same. AI just stands for auto increment. Next, every name has 2 parts, so we're going to call this one first name, and this one last name. We could do middle, but we're just keeping it simple. Next, we're going to change our type. There's no point trying to use an integer to be a name, so we're going to use the varchar. Now we have to set how many characters we want to use. A first name is not too likely to be over, say, 15 characters, so I'm going to put that. And the same for the last name. You could increment it if you think it'll be longer, but for now, this is what we'll use. Now, if we wanted, we can set default values. For first name, for example, we could choose, if no one inputs the name, to set the name as John. And for the last name, if no one inputs it, it'll say Doe. You could also default it to be null or default it to the current timestamp. Next, notice you could actually set your own collation for each variable, but we're just going to use the one that we set for the whole table. For attributes, it's going to change a little bit depending on your type, but the primary thing for integers is whether or not they're signed or unsigned. By default they're signed, but that allows numbers to be both negative and positive. For an ID we don't really need that, so we're going to choose unsigned. This also allows us to go up to the full number in the int range. If we wanted any of these to be null, we could select to allow them to be null. So let's click Save. And now we not only have a database, but we have a table, and that table has 3 columns: ID, first name, and last name. That shows you how to do it in PHPMyAdmin. In the next video, we'll go over how to do the same thing in MySQL Workbench. Now let's go over how to do the same thing in MySQL Workbench. First, choose your connection. If you have different databases, you can select them here, but we only have one for now. Remember, this is just a warning about a version difference. Over here, you can see that we already have the person database we created earlier. Now I'm going to create a new one by right-clicking and clicking Create Schema. Because this is a desktop application, it allows us to do things like right-click, which we couldn't in PHPMyAdmin. We're going to give it a name. Since we already have person, we'll back up a step and we'll call this one Customers. Oops. Next, we'll choose the collation type. We'll choose the same one, UTF-8, MB4, Unicode CI. Click Apply. Workbench does something interesting. It shows you the query that's going to be run before it runs it. This can be useful if you're trying to learn how they're working. Click Apply. It's executed, so now we hit Finish. And now you can see over here that we have a customer database. If I double click it, I can go up here and click Create New Table, and that'll give us our form. Now, I'm going to skip this for now because MySQL has the visual way to do this, which is one of the things that make it more unique, and it uses the same form, so we'll see it in a moment. For now, instead of this, we're going to click File, New Model, Add Diagram, and it's going to open up this page. From there, simply come over and press the table button, choose a place on the map,
And now we've placed a table. If we double click it, we'll see that same form from earlier, and you can actually enter the table name in the columns at the same time. Since we already had person before, we'll name this one person. We'll give him an ID, which is an int. It's already selected that for us. We'll set it as the primary key and not null. And set its auto increment. Over here, we'll give each person a name, and it's selected varchar 45 for us. We can change these things if we want. Each person, if they're a customer, is also going to have something they bought, so we'll say purchase. That should do for now. So if I get out of here, you can see that we have a representation of a table with 3 columns in it. Next, we're going to create one from a template. It has a few already loaded, and this will just save us some time. Now I'm going to go ahead and add a primary key since it doesn't have one. We'll call that person ID, since we're going to try to connect these in a moment. We'll set it as an int, primary key, non-null, and auto-incrementing. Now we have these two tables, and it can actually help us visually connect them. And the more tables you have, the easier it'll be to see how things connect if we do it this way. Also, it has a very handy feature of if you select down here and you select 2 tables, it'll automatically create a table that has the things they have in common in it. In this case, it has the ID from person and the person ID from user copy 1. These are called helper tables and can help you make your queries a little bit easier to use. Now that we have some tables, let's save them. You come over here to File, click Save Model. You can locate it anywhere you want. I'm just going to call this Model 1 for now. Click Save. Now that it's saved, we can come up here to Database, Forward Engineer. All this stuff will just stay the same. And it should be processing. If everything goes well, those are checked. We close it. And now, when we go back to look at our customers table, we can expand tables and see that we now have person, person has user, and user tables. All 3 of them were automatically created for us. And if we expand, we can see that inside there are columns for ID, name, and purchase. Well, that's how to make databases, tables, and columns in PHP MySQL. In the next video, we'll go over some principles on how to best structure your tables so they can be used together. Now that we have covered how to make tables, let's talk about some principles of table design. That is, some things you should think about when deciding which columns will go into which tables. The first and most fundamental is the idea of avoiding redundant data. Redundant data is what we call it when you're storing the same data multiple times or in multiple places. This wastes space and can lead to slowdown or even data inaccuracies if one gets updated and the other does not. Here's an example of redundant data. We are storing Dave's name, address, and email multiple times, which wastes space and makes keeping it up to date difficult. The second thing to think about is how the data will connect and include what's necessary to connect them. We call these keys. You already saw how we set an ID to be a primary key, and that's the primary way that data is going to be connected to other tables. So what does that look like? Well, let's try and fix our table here. First, to avoid redundant data, we keep info about the person in its own table with the primary key of ID. Next, we create the table for purchases. Notice the column on the right called Person ID. It stores the information needed to identify the correct person. We call these foreign keys, and it allows this data to be connected back to the primary key in the person table. Our last guideline is related to the other two, and that is that you need to think about what you're going to do with the data and how you're going to want to view it. This will help you to determine which tables need to connect to each other and which may be fine on their own. An important part of this process that we haven't currently covered is what happens when different people have different needs. This is handled through a combination of users and permissions. There are three main uses of users and permissions. First, it allows you to determine what actions a person can take on a database. You may not want everyone who can see the data also being able to enter new data or update it. The four primary permissions are read, write, update, and delete, and they allow a user to do exactly what you would expect. Next, you may want some people to be able to access some of your data, but not all of it. This is common, especially if you have sensitive information in some tables, but that's okay because permissions can be set per table, so you can choose to allow access only to what you want that user to have. And finally, a user can also be set so that they can only access information if they are making the connection from a specific place. So you could only allow access from your office, or only allow connections from other servers that you own. This greatly helps with security. Let's quickly go over how to create new users. First, select the database you want that user for. We did person over here, so I'll check that one. Go over here to privileges. That'll show you the users that currently have privileges. We can choose to add a new account. Select the username. I'll name mine Justin. A percent means that you can connect from anywhere. If you have a specific location, you'll need to enter its IP. You can have a password, which you'd need to retype, but it'll also allow you to generate a random one for extra security, and we're going to do that. You can see that it's selected to grant privileges just for this table. If you wanted it everywhere, you could check here. Now, all of these here on the right are pretty much things you're only going to want your server administrator to have, but for generic users, you're only going to be using data permissions. Select, insert, update, delete. File also helps if you have files that may be uploaded or downloaded. But we'll give this particular user select and update. Next, click go. And that was created. I've now added a new user. So if we go back to person and go back to privileges, you can see the new user, Justin, has been added. For Workbench, to add a new user, all you have to do is select the table, go to Server, Users and Privileges, Add Account, select the name. You can see we've already used Justin from the one we added in PHPMyAdmin a moment ago. So for now, I'll just name it New Justin. We're going to leave it at percent. It doesn't generate a password, so I'll have to make up one, and I'll use one that I choose to use, even though it thinks it's weak. It's only for a demonstration after all. We click Apply, and you can see New Justin has been added. Now, you can go over to Schema Privilege, choose to add an entry. You can choose whether you want this person to have access for all the databases, or just a selected one. We're going to select Customers, since that's the one we created here. Click OK, and then we can select our Select, Insert, Update, and Delete privileges that we normally have for our users. Click Apply, and there you have it. We have a new user with the permissions we want. Next time, we will go over importing and exporting data. This has been brought to you by CreativeOnlineSchool.com. Welcome! In this video, we're going to be talking about importing and exporting. That is, now that we know how to create tables and structure them, how do we get our data inside or out? Well, when we do that in bulk, it's called importing and exporting. Importing is taking data from an outside source and in a particular format and loading it into an existent table. Exporting is taking data that's already in a table and creating a file with that data in a specific format. The most common file formats are called CSV, XML, and JSON. CSV stands for comma separated value, and it's the most commonly used, and it's what we'll be using in this video. So let's get right to it. In PHPMyAdmin, all you have to do is select the table. Remember, we called this one Person, and its table's name was Name. Click Import. select the file you want to import. We're going to click Name. Now inside of Name, this is what it looks like. You can see that it's encapsulated by quotes and separated by commas. This is pretty standard, and it has a different one on each line. If we scroll down, we can see that it shows us the same things. Columns separated with commas, columns enclosed with quotes. You can change these to be whatever you want, but you have to make sure it matches the file. Next, we're going to click Go. And now, if we go over to Browse, we'll see that there's actually data in our file. And that's importing data. So, to export it, we simply click Export. We don't have to select a template, but we do have to select a format. We'll do CSV again. There's also CSV for MS Excel if you intend to open it in an Excel sheet later. It can be useful. We're just doing it in text though, so CSV. Click Go. It'll automatically name it according to your table name. Click OK, and it's saved the file. It looks exactly like this one. Next, we're going to go over Workbench. In Workbench, we select Customers, because that's our table here, and Person was our table itself. Click this little square next to it, and that'll let you see what's in the table. Currently, it's empty. It also gives you your export and import buttons. We're going to click Import. I'm going to go to where I have the file. It's called Customers. Open. This is a preview of what it's going to look like, but it's not actually saved yet. We're going to click Apply. It'll show you your query, handy if you're trying to learn them. Click Apply. It's finished. And now you actually have the data in the table. To export, you click Export. And then you give it a name and click Save. We already have one called that, but we'll just replace it. And now we have it exported. Now, something to be aware of is this is what the table looks like when it's exported in CSV with Workbench. It's not all new lined. In fact, it's all in the same line, and there's also no quotes. These things aren't necessary. As long as they're separated by commas, it still works, as you saw when we imported it. But different programs can export in different ways, and there's no uniform method. Well, that's it for importing and exporting. Next time, we'll go over how to manipulate data with queries. Brought to you by CreativeOnlineSchool.com. Welcome. In this video, we're going to go over an introduction to queries and query structure, cover some useful learning tools in PHP MyAdmin, as well as constructing some basic queries to select, insert, update, and delete data from our tables. First, let's start with what a query is. Queries are sets of instructions written in a language that can be understood by the database system. In our case, that system is MySQL. Queries have three basic parts: an action, a location, and a restriction. An action, or what the purpose of the query is, will begin with either select, insert, update, or delete. A location, which identifies which table or tables the action will be performed on, will be started by from and the table name. The restrictions, which is the most expansive section, covers what columns and rows of data will be affected. Most of them will start with where and the set of the restrictions. Restrictions often use operators like greater than, less than, equals, not equals, like, or not like. So let's quickly go over some of those tools I mentioned. If we select our database, you can see we already have some data in it from earlier. But up here, there are the search and insert tabs. Those will allow us to do things through a form instead of making a query. Now our goal is to make queries, but they can help us understand what's going on. So if I wanted to insert, I can say I want to insert Smith, and then just click Go. And you can see the insert it created. This is the format it follows. And now we're on the SQL tab,
which is where you will write your own queries. And that brings us to the second thing that it has that's useful. It allows you to have default formats for deletes, updates, inserts, and selects. These tools can be very helpful when you're still getting used to the whole formatting of queries. But let's start making our own. For now, I'm going to use their preset format. This is a select. It's selecting ID, first name, and last name columns from the table name where1. Saying where1 is like saying where nothing. You don't even actually have to have this, but it uses it in the default. And I'll click go, and you see it gives us all the things in the table. ID, first name, and last name, and everything in here. Now, we can edit in line to make things a little easier for us. And if I were to change ID, first name, and last name to star, I'll actually get the same thing because star means everything. That way you don't have to list them all out. So if I click go, I get the same results. Next, let's go back and say where first name equals James. Now, because first name is a character set, we want to put the value in quotes. That identifies that we're talking about characters. If you don't put it in quotes, it's going to assume it's a number, and we'll probably get nothing in this case. So we click OK, and it gives us only the records who have a first name of James. If we wanted instead to use a number, we could say where ID equals 1 or ID equals 4. Because these are numbers, we don't have to use those quotes. And an or means I'll accept it if either of these things are true. So I click go, and you see ID 1 James, but now we have ID 4 Amy. Next, we'll cover making more than one thing true. This one is either, but if we wanted two things to be true, we would change it to and the ID is never going to be the same number. So we're going to do first name again. You can also auto finish with this. Equals James. And remember when we just had James, we got 2 results. But because now we're also requiring the ID to equal 1, we only get 1 James. Next, let's change our search so that we only want the first name and last name. Let's say we didn't care about ID. I can change this to first name, comma, and when I run it this time, ID is no longer in the column. Next, let's, instead of using equals, use greater than. If I say where ID is greater than 1 and click go, you can see that it gives me 9 results. We're missing the first ID. I'm going to go ahead and put ID back in there just so that we can see what else is going on. Now, along with greater than, less than, and equals, there is not equals. So if I said where ID is not equal, that's an exclamation equal 4 or 5, I can click go, and you can see we've got all of them except ID 5. That's not equals. Last, we'll talk about likes. Likes are only used for strings. So let's do first name again. Like, open a quote. We're going to enter a percent. Percent is a wildcard character. It means anything before A, and that's just the letter A, and we're going to put another %. So any A with anything before it or anything after it is acceptable. So I click go, and now I only get the names that have an A in them. And if you wanted only the ones without an A, you can just do not like. And that gives me the others. Now, there's one thing we haven't covered yet. We've been setting everything equal to or like something we're entering. But what happens if you're looking for a comparison of data you already have? So let's say where first name equals last name. And if we do that, then it'll actually look at everything in first name and find the ones that match it in last name. And if we click go, then we'll see Smith Smith, which we entered earlier. We'll be moving along now into the next video, where we're going to do the rest of the updates, inserts, and deletes. Let's move along to the other kinds of queries. Next is insert. The primary difference between inserts and selects is that when you're selecting the table, instead of selecting from the table name, you're going to insert into the table name. The second thing is that there's two different formats you can follow. There's the one that they have here as their example, which lists the columns and then sets the values. If we were to enter values for these, and we're going to remove ID since that one auto increments, we don't actually want to assign any values there. And then we were to just replace these with Bobby Holmes. When we run this one, you can see Bobby Holmes was inserted into our database and the ID was auto increment. Now, the other format that you can use is insert into name, and instead of breaking them out into different sections, you can have set, which is a keyword, first name equal to Sandy, comma, last name equal to Meeks. And if we hit go, you can see that that also got inserted. Now, which format you use is entirely up to you. If there's only one or two values, it's often easier to use the second one. But when you're doing a big list of values, this one's much more efficient. Now we're going to move on to deletes. Deletes are one of the more interesting ones because they're very dangerous. As you can imagine, you don't want to lose your data. So it's much like a select. You delete from table and you have your where condition. Now, the reason they're dangerous is because if you don't do anything to this where condition, it's going to delete everything. So you have to be really careful what you're deleting. So it's often wise to actually run a select so that you can see the data before deleting it. So we're going to run a select, and we'll select star. And to do this as an example, we'll just say where ID equals 5. If we run this, then we can see which record we're going to delete, Sam Johnson. So I'm going to go back to the SQL, paste in the query we had, change select star to just delete. And when I run it, it will delete that record. You can see we no longer have an ID of 5 in here. Next we have updates. Updates use the format update, table name, and then it does set column equal, just like the second set of inserts we saw. So if I were to set, again, we don't have to do ID. Actually, we could do ID in this case because we're not inserting a value. Of course, we don't usually want to mess with those, but just to show you how it works, I'm going to set ID equal to 5 since I know there's not a 5 because we just deleted it. And then first name will be set to Billy Thompson. Now again, your where is going to be important because you don't want to update everything. And if you ran this, it would update everything. So we have to insert our where, and we'll do where ID currently equals 10. We'll update that to 5, and that way we can see the change. And if I hit go and look at the data, you can see we now have a 5 of Bully Thompson, but we don't have a 10 because that one was updated. And that's how to do inserts, updates, and deletes. That's it for this video. Next time, we will begin discussing some more advanced concepts and query techniques. Brought to you by CreativeOnlineSchool.com. Before we go any further into more advanced queries, let's talk about something that will have an important effect on how those queries run: the database storage engine. In this lesson, we will go over what they are and talk about the most common ones and their differences. And then we will show you how to change the engines in both PHP-MyAdmin as well as in Workbench. In short, database storage engines are the things that power the queries that we run. Just like you have different engines in a sedan or a race car or a diesel because of the different purposes of those vehicles, databases can have different storage engines depending on their best use case. There are 4 primary database storage engines: CSV, ISAM and MySAM, heap or memory, and NODB. First, the CSV storage engine. CSV storage engine, as its name implies, has tables that are really text files with comma separated values, just like the ones we were importing and exporting earlier. This allows the exchange of data with applications that can read and write to CSV format, but CSV tables are not indexed, and that can make them be extremely slow when running queries. They're mostly created just to assist with large imports and exports. The ISAM and MyISAM storage engines were designed with the idea that a database will be queried far more often than it will be updated. That is, based on the idea that selects will be what you'll run most of the time. As such, it's very fast when running those, but it can have some issues when you have frequent updates or inserts, especially ones run at the same time. This is because it doesn't support transactions. Each individual statement is run on its own, and they can sometimes overlap with each other if they're coming quickly. Also, it's not fault tolerant. What I mean by that is that if something goes wrong and your disk is corrupted or your hard drive fails, it's quite possible you'll lose everything. MyISAM is an upgraded version, and it allows for table locking and some better fault recovery to address those 2 issues, but it also requires periodic clearing of wasted space, and so is a little bit more labor intensive than the other options we have. Heap, or as it's recently been renamed, memory storage engines, allow for temporary tables that reside only in memory. They are faster than even ISAM or MyISAM. However, there is greater risk of data integrity issues because your data will be lost if it's not saved prior to shutdown. So if the power goes out or it locks up, you're going to lose a lot of your data. It's not really designed to be in long-term use. The last storage engine I'm going to talk about, and the one you may remember us selecting earlier in our databases, is called NODB. It was designed to address the ISAM and MyISAM issues with their transactions and their lack of foreign key support. This allows for better handling of parallel insert updates and deletes, so they're not likely to interfere with each other. However, it's slower than ISAM and MyISAM when it comes to doing select statements. As such, it can be very good for small to medium data operations, but if it's too large, it may need to be used in conjunction with MyISAM or memory, so that you can run the selects from there and then do the rest with NODB. Now that we know a little bit about the engines, let's go over how to change them. Here we are in PHPMyAdmin. All you have to do is click on your table, go over here to Operations, and you can see the drop down for Storage Engine. We currently have NODB selected, but you can choose CSV or MySAM. Depending on the interface you're using, you may have different storage engine options. These are the ones we have for PHPMyAdmin. Next, we'll go to Workbench. To change it in here, you once again go down to your table, just click this little wrench next to it. That'll open this window, and you can change the engine. You can see we have a few more options here. If I wanted to change it to MySAM, I just click Apply, and you see the query, and now it's finished. They're very easy to change, and as such, you can use whatever engine you currently need. Well, that's all for storage engines. In the next video, we will go over some more complex queries, such as how to use multiple tables. Brought to you by CreativeOnlineSchool.com. Welcome! In this video, we're going to be going over joining, specifically what joining is, the different types of joins, some basic queries using joins. We'll then go over how to do multiple joins, as well as how to use the halving clause, which is used with joins. So what is joining? Well, joining is the process that allows data from multiple tables to be used. So far, we've only been running our queries on one table, but most of the time you're actually going to need to use two or even more. The four types of joins are inner, left, right, and full. An inner join, often just called a join, returns records that have matching values in both tables. It's the most common type of join and the one you're most likely to see. If you look at this picture, you can see that of the two tables, only the inner portion where they overlap is returned. A left outer join returns all records from the left table and the matched records from the right table. So if you look at this image, you can see that it will return the entire left table, but only the portion of the right table that matches the criteria. A right outer join returns all records from the right table and only the matched records from the left. As you can see here, it loads the whole right table, but only the matching records from the left. And a full outer join returns all records from both tables when there is a match in either the left or right. So it returns everything where either side has the value you're looking for. So let's get started on those queries. As you can see, I've created a few tables here. But for now, we're only going to be using the name and purchase tables. I've moved to Workbench because it allows us to see our results without clicking around quite as much. Our name table is just what you saw before, and the purchase table has some product names along with a name ID, which relates to the name.id, and the DOP, or date of purchase. So if we wanted to add the name to this list of results, we can simply say select star from purchase, join name, which is the other table we need, on, and this is where we specify how they're connected, name.id. Now, using the dot syntax simply helps you connect the name, the column and the table, because ID exists in both tables. If we don't specify this, it won't know which ID we're comparing to. So name.id equals name_ID. And if I execute this, you can see that it gives us our results. Notice that even though there's 15 names and even more purchases, we've only gotten the results where the name ID equals the name.id. That's what makes this an inner join. To make this a left join, we use the same syntax, but we change join to left join. When we execute this, you can see we've now added the row for peas. That's because there was a purchase for peas, but no name ID was recorded. So now we have all of the products, but we have null for the name because we couldn't match that record. To make this a right one, we change left to right, and when we execute it this time, we get all of the names, but it only has this many products to match. That's because there were no purchases made by these people. So everything else is null. Null just means empty. Now, if we change right to full, we're going to see that it actually gives us the same result as an inner join. That's because it's defaulting to an inner join because MySQL doesn't support the syntax for full joins. You have to achieve a full join by combining a right and left join. However, that requires a few things we haven't covered yet, so we'll have to push it off until later. That's it for this video. In the next one, we'll talk about doing more than one join, as well as the having clause. Picking up where we left off, we'll now discuss how to use more than one table. Now, according to the principles of table design we talked about, you'll remember that we really don't want to be storing the same data more than once. So I've changed our tables up a bit. Name is still the same. However, instead of using purchase like we did before, we're going to look at product, which now has the name of the product as well as a new column for distributor. And we have this other table called purchases that actually contains our date of purchase along with the IDs for the other two tables. So now we're going to need more than one join to connect them. If we start with the basic join we had before, with select star from purchases, join name on name.id equals name underscore ID, then we simply do another join on product with product.id equal to product underscore ID. And if we execute this, we'll see that it actually combines all three tables. It has the name as well as the product and the distributor. However, there's a couple of things that aren't ideal here. First, you can see that the column for your product name is just called name. This could easily be confused with a person's name. Also, when typing these, we're having to use our table names, and that can get long after a while. So we're going to solve both these issues by using something called aliases. To do that, we simply assign another value to the word that we're using. For example, purchases we can shorten to P. Name can be shortened to N. And product could be shortened to Pro, since we already have a P. And then instead of having name, we can just have N. Instead of having product, we can have Pro. And when we run it this time, we get the same result. Also, when we're doing our selects, instead of selecting all of these different IDs and a name that doesn't fit with our data, we can simply select what we want. So we can say name underscore ID product underscore ID DOP first name last name. Oops, that isn't capital. And then instead of using, we'll still select name, but instead of calling it name, we're going to say as product name underscore name. And we don't care about distributor right now either. So now when I execute, we're going to get a much cleaner list. Instead of name, it now says product name, so I can keep it clear. And I didn't have to retype the table names every time I was getting specific. In fact, if I wanted to add the IDs, I could even say p.id, n.id, and pro.id. And then I can add those IDs back in the select. And I could give them some names if I needed to keep them uniquely identifiable. So the aliases work both ways. But for now, we'll go back to our original information. From here, we're going to talk about the having clause. The having clause allows us to further filter our data now that we have it looking the way we want. To use the having clause, we'll go to the next line and simply type having, and let's say we only want them after a certain date. So we'll say DOP greater than, and we'll put it in quotes because it's not an integer, and we'll hit execute. And now we'll see that we only have the results that are further filtered by having a date later than the one we selected. Now this looks a lot like the where clause, and in fact you can even use them together, where last name like O and now we only have the ones that are after a later date and have an O in their last name. However, there is a few differences. The where is going to happen earlier on in the process than the having, and there's some things that can come in between, and we'll talk about those in a later video. Well, that's it for joins. In the next video, we will cover some of the things that you can do with the query results after you get them. Brought to you by CreativeOnlineSchool.com. Welcome. In this video, we're going to be talking about the different ways to manipulate the data after you've retrieved it. Specifically, how to order your results, performing arithmetic on them, some string manipulations, and using the results you get as further query restrictions. So let's get in there. If we look at our purchases table, I've added a column for amounts, but other than that, it's the same. And currently we're looking at these results based on the order of the ID. That's the default because we're just selecting star, we're not giving it any further instructions. But what if we wanted to order it by, say, the date of purchase? Well, to do that, we would go to the end and say order by DOP. Now, by default, it's going to order it in ascending order, or ASC. But as you can see, that orders it from oldest to newest. However, what if we wanted it the other way? Well, to do that, we would do DESC, or descending order. And that gives it to us from newest to oldest. It can do this because we've correctly labeled these as dates, so it knows how to order them. We're also not limited to only one order. As you can see, there's two orders on 910 and two orders on 810, and their product IDs are 13 and 94. Those aren't in any particular order. Well, what if we wanted them further ordered by product ID? We could simply add a comma and then do product ID descending. And now, not only are they ordered by date, which is first, but they're ordered by product ID in descending order. You can have as many of these as you wish. Now that we know how to order them, let's move on to a little bit of math. Let's say we wanted to do some calculations on these. Now I'll just be using mostly random numbers here for example, but you'll see what I'm talking about. So we're going to add amount to this result, but we're also then going to add 1 to it. So if I run this, we now have a new column, and it's calling itself amount plus 1 for now. We could name it with the as we saw in last video. But we now have this, which is amount plus 1. We can also subtract with a minus to have 1 less. We could multiply by 2. Multiplying in SQL is done with the star. That's going to give us a multiplied amount. Or we could divide. Dividing is done with a slash. And you can see we can even get results that have decimal places. That brings up another important point. What if you get a result that's not quite what's in the format you want? This one has decimals. Well, we can fix that. If we want to round down, we use the word floor, and then we encapsulate it.
By doing this, it rounds everything down. And if we wanted to go up, we could use ceil, and it rounds it up. So that shows us how to do numbers, but what if we wanted to deal with strings? Well, let's go over to our name table. We have the names first and last, just as we wanted it, but what if we wanted instead to have the names together as full name, or what if we wanted the last name to be first? Well, instead of selecting star, we can select concat, short for concatenation. We open this up and we'll type last name, because that's what we want first, comma. We'll put an empty space here so that there's a space in between, and we'll enter another comma, and then we'll do first name, and we close it. So now when we run this, we're getting Donovan James as one field. Well, that's great for combining things, but what if you only wanted part of the name? Let's say we only wanted the first letter of the first name. Well, we can do that with a substring. In here, we can put substring, or substr. We'll open it up. We'll use the same name, but now we'll add a comma, and we have to select the positions that we want. Because we want the first letter, we're going to put 1, comma 1. This is from position 1 to position 1. And then we'll add another close. And when we run this, you'll see that we now have Donovan J, Patterson A. And if we wanted to go to 2, we would just change this to 2, or 3 in this case. And now we have the first 3 letters of the last name. That's how to manipulate characters. We'll continue on with how to use these things we're making to help further restrict our results in the next video. Let's pick up where we left off. We're going to talk about using some of those custom things we were making to further restrict our searches. Let's start with something simple. Name underscore ID plus product underscore ID. And we'll go ahead and also select star so that we can see the data. And we'll name this total just so that we can refer to it a little bit more easily. When we run this, we see our data, but we also see a total, which is product ID plus name ID. But what happens if we want to see the totals and only the ones greater than 10? Well, let's try it with a where clause. Where total greater than 10. It didn't work. That's because the where is looking for the information before it's created, because we're creating it as part of the select. But we have a solution for that. Remember how we discussed there was a timing difference between where and having? Well, if we use having, that takes place after the select, and so now we get the results we expect. Results of only those greater than 10. Now, as you can see, there are different product IDs, and there's different instances of, say, product ID 7. So what if we wanted to know the total amount of all of product 7's entries? Well, we can do that with a command called sum. Go over here and type sum amount. We'll leave it named total. And we'll have to set this equal to product ID equal 7. Otherwise, we'll get a total of everything in amount. So we'll execute this. Oh no, it didn't work again. Well, that's because having doesn't have access to the information that's not created from the data. So this one needs to be aware. The basic policy is that if it's in the data already, use aware. If it's something you're creating as part of the query, use have it. Now when we execute it, you'll see that the total for all of those amounts is 13. Now let's say instead of sum, you wanted to find the average of the numbers. You can simply change sum to average, or AVG. When we run this, you'll see the average of those numbers is 3.2500. We could floor it or seal it if we wanted to round it off, but we've already seen that. Next, let's move on to something a little different. What if we had data that we knew was supposed to be entered in a particular length, but may have been entered inaccurately? How would we find the correct ones? Well, we can do that with the length command. Let's say select length, first name, as total for naming purposes, and we'll also select star so that we can see exactly what we're lengthening. And remember, because we're creating this in the query, this is going to be a having command, having total equal to 5. If we run this, then we only get the results where there are exactly 5 characters in the first name field. This is very handy if you need to validate data of a particular length. That covers most of the basic things. In the next video, we will cover how to use these data manipulations more efficiently and how to get multiple results with grouping. This has been brought to you by CreativeOnlineSchool.com. Welcome. In this video, we're going to talk about grouping. Specifically, grouping as it relates to data, how to use grouping to get a single result, how to use grouping to get multiple results, how to use grouping in combination with other query actions, like the math or string manipulations we've already covered. So, grouping as it relates to data. Grouping allows us to consolidate multiple rows of a result based on a common data value. That means if our original query produced 5 rows, but they're all for the same person, we can consolidate it down to 1 row. And that allows for the production of a result set that contains only the information that we care about. Well, let's see it in action. We're back in Workbench, and we've already got loaded up a query you've already seen. It's joining the name, product, and purchases tables, and in this case, we're doing it where name ID equals 1. That's the name for James Donovan, so that we can see all of the purchases that he's made. And he's made 3. But what if we only wanted to produce 1 result set? Maybe we're looking a result that's going to be fed to a program that's going to insert his name into an email. Well, we don't want to get 3 results back because he only has 1 name. Well, to resolve this, we're going to do group by. And we're going to group by, in this case, first name. When we run this, notice that we only get 1 record. And if all you need is a consolidated report and based on first name, you're fine. But what if we wanted to go a step further? What if we wanted to see what his most recent purchase date was so that we can include that? Well, normally you do that by ordering. And if you order by DOP, descending, you would think that would give you the most recent date. However, it doesn't. That's because the order by happens before the group, and the group rearranges everything. So if we want the most recent date of purchase, we're going to have to do that in the select. We'll get rid of the order by for now. Here, we can select the max DOP, and we'll go ahead and name it max DOP. And when we run this, we've now got a new row. It's showing us the most recent of the dates for James. Well, let's take it even one more step further. What if we wanted to use some math on these functions? What if instead of just some random amount in the group, we wanted to know the total amount of all of his purchases? Well, we can do that too. In the select, we just add some amount. Because the group by is in effect, it knows what value set you're looking at, and so it will automatically sum them. And so we know the total is 18. He's bought 18 products, and his most recent purchase is on this date. You can see how this kind of stuff becomes more and more useful the more you add. We'll stop there for now and continue on with the rest in the next video. Picking up where we left off, we have a max data purchase and the total amount of his purchases for James Donovan. So what if we're not just looking about James? What if we want to use everyone and find out their maxed data purchase and how many products they purchased? Well, if we remove our where so that we're no longer caring specifically about him, we'll get that list. It's a list of one name and that name's max data purchase and how many items they've bought. However, we've run into an issue because we no longer have the ID requirement and there were people with multiple first names that were the same in our database. That's why these numbers are so high. So instead of grouping by first name, we need to group by name.id. Because that's a unique field, we'll know that we'll only have each person once, even if that person has the same name. When we run this, that looks better. Now we have the totals for every individual person that's in our database, even if they have the same name. And we could further refine it with our having clause. We could also say having a max DOP. We did rename that accidentally up here, but it's fine. Greater than 10. And now we've even further refined it so that we only have the most high purchased people in our list. But what if we wanted to add some more information? What if instead of looking for the highest people, we wanted to see the total that each person bought of each product? So let's get rid of that having for a moment, and we'll add another group by. We'll do that by simply adding a comma and now saying name, because name is the field that we have called the name of the product. Now when we run this, we'll see that we not only have the max data purchase for James Donovan, but we have two of them. That's because this is the max date when he bought flour, and this is the max date when he bought butter. And he's actually bought butter twice. That's why his max of butter is 15, but his amount is only 7, because one of the times he bought 7 and one of the times he bought 8. So this breaks it out even further. Now we have a list of the total of each product that every person has purchased, as well as the most recent time they've purchased that product. That's starting to sound like some real business data, isn't it? Now, one of the things that often comes up is if we're selecting their name and there may be other personal information like their address or phone number, how do we make sure that we get the most recent record? Since we're currently selecting what amounts to a random one of these in the group, how do we ensure that we get the most recent and up-to-date information? Well, we're going to have to add some more content. It's called subqueries. And subqueries are going to be what we cover in the next video, as well as the uses for the null value. This has been brought to you by CreativeOnlineSchool.com.
Welcome to the second part of the MongoDB lecture series. In this video, I'll show you how to get MongoDB set up on your computer so we can start playing around with it. To get started, visit MongoDB.com in a browser and click Download in the top right corner. This will bring you to the Downloads page. Click Community Server and select the operating system that you're running and click Download. To save us time, I've already downloaded and extracted the archive from MongoDB.com, but while you're waiting for it to download on your end, MongoDB requires us to create a data folder. If you're on OS X, navigate to the / directory and create a new folder called Data, all lowercase. Inside of the Data folder, make another folder called DB, all lowercase. Great. Now let's return to the folder that we just downloaded from MongoDB.com. Inside, you'll find a bin folder. Open this folder and you'll find a number of executable files. Before we can use MongoDB, we have to run it locally. To do that, open the MongoD executable. This will open a new terminal window that prints the details of the MongoDB server that is now running. If that went well, then we can return to this folder and open the Mongo executable. This will open a shell that allows you to interact with your database and execute commands. Now we're ready to build a database. Stay tuned for the next video where we'll create our first collection and perform some basic queries to add and modify documents in that collection. Welcome to part 3 of the MongoDB lecture series. In the next couple of videos, we'll be going over some basic and advanced actions that you can perform in the Mongo shell. In this video, we'll be going over how to create documents and how to search documents. Type show DBs once you're in the Mongo shell, and that'll show the databases you have. Type use and database name to either create or use a database if it exists. So now that we're in our database, we can create a collection. To do that, type db.createCollection and the name of the collection you want to create. And now that we have our friends collection, let's insert some documents into it. To do that, use db.friends.insert, and in here you put in a JSON object. So let's make a name property where the value is John and an age property where the value is the number 23. Great. Now if we do db.friends.find, we'll see the document we've just created. Let's insert a few more documents in here. Let's make a Mary whose age is 25 and a Bob whose age is 24. Now we have all three of our friends. And say we want to narrow down our search. All we have to do is pass in a JSON object into the find function. So say we want to display only the documents that have the name John. Then you would do it like this. Say you want to display or find only the documents where the age is 23. You can do that too. And you could also search for all the documents where the age is greater than 23, for example, using the greater than operator, $GT. So $GT is an example of an operator that you can use. There's a whole lot of them, and I'm not going to go over all of them. So you can find, if you're curious, all of them on docs.mongodb.com. So that's the basic usage of the find function for narrowing down your search. Say that you also want to narrow down the number of fields that are returned. So for example, I want to hide the name field. To do that, you pass in two arguments into the find function. The first is your search term, and the second defines the fields that you want to display. So I want to just display age, and here you see that _ID is still returned. That's because by default you have to explicitly define for MongoDB to hide it. So you set that to 0. I should also mention that _ID is a unique identifier that's automatically inserted into new documents by MongoDB. Say we want to sort our results. Well, we just append a .sort, and we specify that we want to sort in ascending order of age, like that. Or we could use -1 for descending order. Pretty simple. And finally, say that we want to limit the number of results we get back. So if we do an empty find, we get 3 results back. Whoops. But say we only want 1 result, then we would do something like .limit of 1, and we only get 1 document back, or .limit of 2. If we do .limit of 4, we get 3 documents back because the 4 only specifies the maximum number of documents we want back. So that's how to both create and search documents in MongoDB. In the next video, we'll be going over how to update and delete documents. See you next time. Welcome to part 4 of the MongoDB lecture series. In the last video, we went over how to create and search through documents, and in this video, we'll go over how to update and delete documents. To update documents, you would use db.collectionName.update, and the update function takes in 2 arguments, the search term and the new data that you want to add. So for example, if we wanted to add a gender field to all of our existing documents in the friends collection, we would pass in an empty search, and we would use the set operator and define gender to be M for all of our documents. Now you can see that it only modified one of our documents, and that's because by default update only updates one document at a time. So to ask it to update more documents, you have to set the multi option to true by passing in this third argument. And now it did apply the changes to all the documents. We can also target particular documents. So say that we want to change Mary's gender, set it to female. Then we would do it like this. And say that we wanted to get rid of the gender field for all of our documents. Then we would just use the unset operator instead, and we would do an empty search, and we have to make sure that the multi-option is true. And if we want to update a document in its entirety, so in other words, to replace a document, let's say that we want to replace John. Instead of using a set or unset operator, we would just pass in a completely new document here. So let's say that there is a John 2, and he has a favorite food field where it's pizza. So we replace the John document with this new document that we passed in here. So that's how to update documents. Let's go over how to remove documents. Very simply, you just use .remove and you pass in the criteria for the documents that you want to remove. So let's say we want to remove John 2, or all the documents where the name is John 2. It'll happen like that. Say we want to remove all documents, we just pass in empty braces. And so we have no more documents in our collection. And finally, to drop a collection, all you have to do is do the collection name .drop. And you can see that we no longer have our friends collection. So that's how to update and delete documents in MongoDB. Welcome to part 5 of the MongoDB tutorial series. In this video, we'll be going over document relationships. We'll be discussing why relationships are important to consider, and we'll be talking about the 3 different kinds of relationships: one-to-one, one-to-many, and many-to-many. You need to worry about the way that your documents are related and the way that you define those relationships, because if they're defined poorly, then that has a direct impact on the performance of your database. And no one is going to want to use your website, for example, if the data loads slowly. So in order to optimize performance, you need to intelligently plan how you design your database architecture. For example, if you have a website like Amazon.com, there is an optimal way of associating all your products and all your manufacturers so that everything loads quickly. The first kind of relationship to consider is a one-to-one relationship. You don't need to overthink this. It's pretty simple. You just need to have, so for example, if we have a database that has users and home addresses, and each user has one address and each address has just one user, then we can simply define the user object and define the home address object, and in either one of them contain a reference ID to the other. So here in the address, I've defined user ID is Homer, and that links this address to this user. So if I, for example, was looking at this user and I want to find his address, I would do db.addresses.find where user ID is equal to Homer. So that's pretty straightforward, and you don't need to overthink one-to-one relationships. One-to-many relationships become a little more complicated. Say you have a newspaper website where you have articles and comments. Here's an example of a poorly defined relationship between articles and comments. Here's a whole article object, and it has a comments array. So all the comments on the article are nested inside of the object. So this is fine if you want to load all the comments for an article while you're loading the article. But say you want to upvote any one of these comments. You would have to go through the entire comments array until you find the comment that you want to modify, and then only then could you change this upvotes counter on any one of these nested comment objects. When there's 2 comments, like in this example, it'll work just as fast, but you need to consider scalability. When there's 1,000 comments in this array, it's gonna be a clear bottleneck on your performance, and every single time that a user wants to upvote a comment, you would have to go through this entire array and find the appropriate comment. So this is a bad way of structuring article and comment relationships, or one-to-many relationships. A better way is to do something like this. Define an articles collection and a comments collection. So here's the article on the left. There's no longer a nested comments array, and instead we define the comments as as individual documents in the comments collection, and each comment has a reference to the article. So each comment has an article ID reference that links to the ID of this article. So therefore, if you want to find all the comments, if you're loading this article on a web page and you want to find all the comments along with it, you just need to run a command like db.comments.find, where article ID is equal to article 1. And that would that'll happen at the same speed as loading this. But say that you want to, the reason why this is better is because if you want to upvote any particular comment, you no longer have to traverse through this comments array. You can just specifically refer to any one of these comments and change the upvotes counter. And then there are many-to-many relationships. An example would be comments and tags. You can have a single comment can have many tags, and a single tag can have many comments. So here on the left we have comments with tag arrays, and these tag arrays contain IDs of the tags that are associated with each comment. And then on the right we have all these different tags, and so if we want to find all the comments that contain a particular tag, we do something like db.comments.find, where tags contains tag 1, and that would get us what we want. So that's an optimal way of structuring many-to-many relationships in MongoDB. So that's all for relationships in MongoDB. Next up, we'll be talking about indexes. Welcome to part 6 of the MongoDB tutorial series. In this video, we'll be discussing indexing and how that can be used to make your database much faster. Indexes are special data structures that make it easier for MongoDB to fetch records from your database at much quicker speeds. So I made a comments collection, and I've inserted a couple of comments here. And now say that I want to find all of the comments that are written by Homer. I would do a find query like this, where I set author to Homer, and I would execute it, and it would give me the document I want. However, the more comments that I have in my collection over here, the longer this query will take to execute, because in order to find all the documents where the author is Homer, it has to go through the entire collection and check each author field to see if this author is Homer, if this author is Homer, if this author is Homer, and so on, until it gets all the ones where the author is Homer. So the faster way to do it is to create an index. That allows MongoDB to not search through the whole collection, and it can actually instantaneously get all the documents where the author is Homer. So to do that, you set ensure index, and you define an index on a field. So we're going to define it on the author field, and we're going to write 1 to define it in ascending order. So now we have a index on the author field. So if we write get indexes, we'll see the one that we just created, author_1. Also note that there is automatically an ID index by default, and that's the reason why when you're given the ID of an object, you're able to automatically fetch it instead of having to traverse through the entire collection. MongoDB does that by default, and so that's pretty neat. And you can drop an index like so. You use the drop index command, and you put in the name of the index that you want to drop. So we just drop the author index. Now we can also make indexes on values inside of arrays. So say that we want to make an index on tags, we can do that pretty easily by doing db.comments.ensure index and tags in ascending order. And then all we have to do is db.comments.find tags, and then wherever we search something like this, tags where pizza is contained in the tags, we'll get, for example, these two documents where pizza is contained in the tags. And so by creating an index, that operation becomes much faster. And finally, we can make a index on text. So the way that works, say that we want to search through the text of each of these comments. So I want to find all the comments that mention the words MongoDB. Very simply, I can do another ensure index command and write that I want to make an index on the body field, and I define the type as text. Great, now I can do db.comments, or yeah, db.comments.find, where $text operator is equal to $search operator and the text that I want to search. So let's say I want to search for MongoDB. Great, and it gets us what we want. Say I want to search for comment, and it gets me all the comments that contain the word comment. So that's how to use indexes in MongoDB. And in the next video, we will be discussing our first small project, so you can get a hands-on look at how to use MongoDB in your project.